All right, so we're back and we're ready to wrap this up. We have just a little bit of time left. And I've come around and looked at your tables and your graphs. Make sure that you've looked at each other's and you're all on the same page. So as I mentioned, we are back to the do now. How do we find slope from a table? What did you write for how you found slope from a table? Who have we not heard from today? Daniel, how did you answer that one?
I subtracted the first coordinates, -2 and 5.
Are those x coordinates or y coordinates you're referring to?
Those are x and y.
Okay. So you looked at the top two on the x side and the top two on the y side?
No, I made those into points where it's -2, 5.
Okay.
And then I subtracted those by 0, 9, and then I got -4 over -2, which I got 4 over 2. And then
Okay, you might want to double check your calculation with the negative, because remember a negative times the negative that's already there is going to equal a positive. So double check that, but your description was great. You made them into points, and then you can calculate from there. Or we could just look at the table and find change in
X,
y and change in x and put them in that ratio.
I just put delta. I mean,
That
delta y.
shortens it up, doesn't it? And it just makes you feel so cool when you're writing Greek. Now, when I'm looking at the table, how do I know which one is the y-intercept? Michael?
As you can see, the first x variable is in the negative side, and the second x variable is at the 0, so that means it's going through the y-intercept somehow, the y-axis. And so once you find all the y variables, and basically the second order pair, or x and y variables, is the y-intercept.
The values, you mean. Yeah, so when x is 0, that's it. You refer to that line in the chart. And how do you find the slope from a graph? Some of you love finding a slope from a graph. Justin, how do you find the slope from a graph?
Well, you just take the rise and run.
Well, your graph's blank right now, so you better back me up a little bit more.
Well, you just take the equation, really? Wait, I have to find the slope.
From the graph. You are correct. I really want to use rise over run. My only issue is right now my graph is blank.
Oh, then you gotta put the, you gotta use the equation to put the variables in the table, and then you
Variables are letters, so I have to use the equation to put the
can,
values in the table,
Sorry.
and then
You put the points on.
put the points on the graph, and then
You use rise over run.
I can count rise over run. And how do I identify the y-intercept on the graph? Autumn.
It's the point where x is 0.
Yes, and what does that look like on our graph, the point where x is 0?
Not maybe it's on the y.
So it's the spot where my line crosses the, let her answer, the y-axis. So it's where it crosses the y-axis. Excellent. So I'm just going to pause for a moment just to shift the page, and we're going to go over example 1. If you don't have it by now, before you leave here, you need to take the sheet. You will receive the sheet that is the activity 2.6 practice. This will be due on Monday. So tomorrow, or when you're in the lab, if you're done early, this can be where you go from there. You can do it before you do the lab work, after. I'm not sure how that's going to work best for you. I'm going to pause and shift the page, then we're going to go over example 1, and we're going to wrap this up. All right, so whether you're in block 3 watching this video for the first time, block 5, some of our friends who are still in the Bahamas watching this video for the first time, or whether you're watching it for the 12th time, you might notice that things look a little different before I pause and then the view after I pause. That's because I'm shifting back and forth from Active Inspire, when I was trying to write on it, to just the actual PDF itself, which is a little bit closer to, a little bit clearer, because a little bit easier for me to manipulate. But I wanted us to look at example 1 because this is something that you are going to have to do on the practice sheet as well as on the Math Excel assignment. And I want you to notice that we're starting right here with the definition. The very first line of the step 1 is the definition of slope-intercept form. Y equals mx plus b. So that's a little bit, it's not too new to us because our direct variation and inverse variation, those definitions were just equations, and this is as well. So we have y equals mx plus b, m is the slope, b is the y-intercept. We haven't talked about x and y today, but what are x and y?
On the input and output.
An input and output, and when we have x and y together, we call that, Justin?
Domain and range.
Well, domain and range, yes, but when they're together, hugged up in a parentheses, Sam? X and y together with a little parentheses hug.
Friends. The concept.
Friends, yes, Kareem. Coordinates, 2n. Ordered pair. So they're an ordered pair. So when you read underneath example 1, write the equation in slope-intercept form of the line that passes through the point 1, 4 and has a slope of -3. These two numbers, 1, 4, represent what, Eliana?
They represent the
X and
the y.
y. And the slope represents what, Jenna?
The slope represents the change in
Yeah, which variable, though, in our equation?
it stands for the mx. Wait,
Just,
it wasn't for b.
nope, b is the y-intercept. Not mx, just m. So I have x, I have y, I have m. So you can see they substituted those in. The only variable left was b. Did a little bit of math. B equals 7. We don't stop there. This is where a lot of you were getting into trouble with your quiz with your direct variation equations. You would find the constant of variation and you would stop. No, look at step 2. Substitute the slope and the y-intercept into slope-intercept form. So they went back to the definition, put in m, put in b, and x and y stay x and y. My question for you is, why do x and y stay x and y? Max?
That's the equation for the slope.
And what does xy represent?
Direct variation.
We're not in direct variation anymore. X and y together. Sam?
They're ordered pairs.
It's an which ordered pair?
Like any ordered pair.
Not just any, but every ordered pair. So there is an xy combination. How many xy combinations are there that are going to make that equation true?
One. No, infinite.
An infinite amount. And if I graph every xy combination that makes that equation true, what is that going to look like?
It's going to be.
No.
It's going to have a 7 like that.
That's a
y
good
intercept
thought.
is 7.
If you put in 1, 4, it makes the equation true.
Yes.
And if you chose an x of 0, y would be, if x is 0, look again, 7. And if x was -1, could you get a y?
Yes. You
And
could.
for every x that you can come up with, you're going to get a y. And if you plotted all those on a graph, what would it look like?
A linear function.
A linear function, which means, Michael, it would be a, if it's a linear function, its picture is a line. And I can tell you that my line crosses the y-axis at 7 and has a slope of negative slope. The slope is actually, Michael, -3. So I can tell you some things about the line. All right, we're going to scroll just a little bit more. I know you're watching the clock. I'm watching the clock as well as the time on this video. We've got try these A, B, and C. So you need to work on those. And hopefully, if we don't debrief it here, I'll go ahead and tape a little thing that just runs through the answers so that you have them there. So you need to make sure that you're working super diligently for these last couple minutes. Try these A, B, and C. You have this example to refer back to.